Now you'll be surprised to know that flipping coins has a lot to do with expanding binomials. Okay, the binomial x plus h here is expanded to the third power. So we can write out what that means. X plus h times x plus h times x plus h. Okay, now, we know by the distributive law, and we've done this and everybody can do this, that if you multiply two of these x plus h's and then multiply that by x plus h using the distributive law at every step, you get x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay? We're confident of that. Now I'm going to show you how you do it using heads and tails. Now this is not a random process, but let's see how this works. Okay, we're going to flip a coin for each x plus h, for each binomial. And we're going to choose x from that binomial if we get heads, h if it's tails. Now, what can happen if we flip 3 coins? Okay, well, if we get heads, 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 then we're going to pick x here. We're going to pick x from this one. We're going to pick x from this one. Okay? If we flip heads, heads, tails, what are we going to get? We're going to get an x here, and an h here. What if we get heads, tails, heads? Well, then we get an x here, we get an h here, and we get an x here. Let's go heads, tails, tails. We get an x here, we get an h here, we get an h here. Okay, now let's say we have tails, heads, heads. That means we're going to get an h here, an x here, and an x here. Or we go tails, heads, tails. That's going to give us an h, then a x, then an h. And tails, tails, heads will give us an h, and an x. Tails, tails, tails will give us an h, and an h. So what do we end up with? Well, if you think about how the distributive law plays out here, basically what we're doing is we're picking either an x or an h from each binomial in each possible way. Once in each possible way, once for each possible choice. So the result is going to be the sum of what we get from all 8 possible choices. Okay? And of course, since we're multiplying the binomials, this means we're going to multiply x by x by x. If we choose x out of each one, we're going to get x times x times x, and that's what? That's x cubed. Okay? Then if we choose heads, heads, tails gives us x, x, h, that's x squared times h. Then heads, tails, heads gives us x, h, x. Well, that's also x squared h. Heads, tails, tails is x and 2 h's. That's x, h squared. Tails, heads, heads. Well, we got 2 x's and an h. That's going to be another x squared h. Heads, h, x, h. Tails, heads, tails is going to give us h squared times x. Tails, tails, heads, 2 h's and an x is h squared x. And heads, heads, heads is h cubed. What do we get when we add all these up? Well, we've got x cubed. That occurs just once, so let's just kind of put a check mark over here to indicate that we've got this. Then we have an x squared h, an x squared h, and another x squared h. That's 3 of them. And I think that's all the x squared h's. I know it is if I listed these correctly. So we got 3x squared h. And then what? Well, there's an xh squared, an h squared x, which is the same as an xh squared, and another h squared x. Same thing, so we can check these three off and say that we've got 3xh squared, leaving us only this h cubed here. Now we've got all 8 possibilities checked off. Now again, multiplying these 3 binomials, each term in this binomial will multiply each term in this binomial multiplied by then a selection of each term in this binomial. I didn't say that particularly well, but if you think about it, you'll understand and you'll see that this is exactly what you get. Now we could write this out by the distributive law and confirm exactly the same thing. If we just write out every term, it'll match these terms. Now this is going to be the case for any binomial expansion. If we want to do x plus h to the 5th, then, well, we could list out the 32 different ways heads and tails could come up. And what we get is going to correspond to the 32 different terms you would get in multiplying those 5 x plus h binomials. Now remember that HHH is the number of ways we can get HHH, which is just 1 of course, is h of 3, 0, and that's of course 1, and that's how many x cubes we have. And then h of 3, 1 is the number of ways to get exactly 1 head. And I said that wrong. If we get 0 heads, we're not getting x cubed. If we get 0 heads, we would get this term, which would be h cubed. So, and I started to say this one wrong too, so I've got to fix that. Okay, so it's h of 3, h of 3, 0 times h cubed. And I don't want to say it that way. Unfortunately, I don't have time to start this video over and fix that, so I'll just have to live with that little glitch, and we'll say it the way I wanted to say it. And there's a lesson to be learned from this, so hopefully you can learn something. Okay, if I want the ways to get x cubed, that's the ways I can get HHH, because that's the way I can get 3 x's. And there's only one way to do that, and that's h, not h of 3, 0, that's h of 3, 3. Bit careless when I wrote that down. Okay, how many ways can I get x squared h? Well, to get an x squared, I got to get 2 heads, because I got to select x from 2 of these. The way of selecting 2 heads is h of 3, 2. And that's going to be times x squared h. And then if I want to get xh squared, how many ways are there to do that? Well, to get an x, I've got to get 1 head. To get an h squared, I've got to get 2 tails. So there's just 1 head involved, so that's h of 3, 1 times xh squared. Didn't leave myself enough room to write that, but hopefully you can see that. And then you can certainly see why we have h of 3, 0 times h cubed, because h cubed comes about when you don't have any heads. Well, if we want to write x plus h to the n, we just write h of n times x to the n, because, well, h of n is the number of ways we get all heads. There's only one way to do that, but if we do, we get all the x's. And then we have plus h of n minus 1 times what? Well, if we get n minus 1 heads, then we're going to have x to the n minus 1, and the remaining one is going to be a tail, so we're going to have an h. Then h of n minus 2 multiplied by x to the n minus 2 times h squared. And again, we're getting 2 tails and n minus 2 heads. So we're going to have x to the n minus 2 h squared, etc. Now, what does this have to do with anything that we've done about power and exponential functions? Well, I'm going to come around to that in a minute.